So there's only a few exercises in this chapter, so we're going to be combining it with the next one as well. But this chapter focuses on solving different types of trig equations. On the front here, you can see all the different trig formulas that you get given on your formula sheet. Please remember that the double angle formula, I've written those on the side there in green. You do not get given those, but you do need to use them. You can derive them from the compound angle formulas up the top there if you'd like to, or you need to memorize those because they're very, very useful ones. Okay, so we're going to solve equations that involve compound angles today. But first question is not actually a solve, it's a sketch. It says to sketch y equals sine squared x and state the amplitude, period, and range. Now we've sketched trig functions before, but we haven't really sketched them squared. Okay, so what can we do? Well, there is our compound angle formula, which would enable us to change from a double angle into a sine squared, right? So let's have a look at that rule, which is cos of 2 theta, if I use the double angle formula for the compound angle, that is equal to 1 minus 2 sine squared theta. Okay, that's just copying down my compound angle formula, my double angle formula for cos. Now I want to get the sine squared by itself, so let's move it across the other side and make it positive. And that would be equal to 1 and subtract the cos 2 theta back to the other side. Now remember, I'm trying to get the sine squared, so let's divide by 2. So it would be half minus half cos 2 theta. So what I've done is I've made an alternative type of equation to sketch. Instead of sketching y is equal to sine squared x, I'm actually going to sketch half minus a half cos of 2x. Okay, just a rearranged version. Because that kind of equation we can sketch. It's not pretty, unfortunately, but we can do it. The 2x is going to change the period of the graph. So maybe let's consider that. Let's just start with, I'll change colours here. Let's just have a think about the cos of 2x graph. We know that the period of that graph, what would the period be? Not quite. What did you say? Pi, yes. Normally the period of the cos graph is 2 pi, and you divide it by whatever is in front of your x there, which is a 2. So we've got 2 pi divided by 2. So the new period of my graph is going to be pi. Now, what else has happened to this form of my equation here? What does the half in front do? Well, it's actually a negative a half. It's going to change the amplitude to be a half, and the negative is going to be turning it upside down. Okay, so we've got turned upside down. The amplitude is a half, because the half that's in front. And the positive half that's sitting at the front there, what does that do? Yeah. Okay, so that's all the information we need. Now we just have to try and get all of that onto a diagram. Okay, so nice little Cartesian plane over here. Okay, we're thinking about the cos 2 theta graph. Normally, actually let me draw a little bit of a scale on here first. Normally cos theta starts where? Yes. So I need to turn that upside down. Well, let's halve it first. I had to halve that amplitude, so it's half. Turn it upside down, which would be negative a half, and then move it up half, which is back to 0. Yep.
Oh, right, the amplitude changes. It goes down.
So that's right. So really, yep, let's start it all again. It's a lot of steps to try and do all in one thing, but I don't want to draw because that would be even messier. If you try and draw the 4 different versions on your graph, it'll be a nightmare. All right, so cos graph, I'm going to do it in green, say. It would start here at 1, right? If I want to halve the amplitude, my amplitude comes down to a half. Then I need to turn it upside down. So I'm going to go down to negative a half. So I'm reflecting it, negative a half down here. And then I have to move it up half, which brings me back to the origin. Okay, you can you could sub in that x is equal to 0, and you could go cos of 2 times 0, which is 0. Cos of 0 is 1, and so you have a half minus a half, which is 0. Okay, but that only works nicely because it is a whole number. If it comes out as a pi or something, that's not going to be so easy to do. But once you get 1 point, usually the other ones are easier.
You fit up.
Yes, because we reflect it down to negative a half first, remember? Yeah, because we had, yeah. Yeah, it's easy if you start with like the cos 2x and keep going from there. So from the cos 2x, change the amplitude, reflect, go out. We'll make it easier. Now, if we know that the period, if we've got that one starting point, all right, we know that the period of the graph is pi. So over here at pi needs to be one complete rotation. What is the amplitude of my graph? A half, that would be half to the middle, which means it would be a positive 1 to go all the way to the other side, right? Half up, half down from the middle. Yeah. What's actually happening is it's going to go this way. It has been.
So what's that?
Because, sorry? Half. So that's a 1 and that's a half there. So what has happened is if we took the, thinking of, maybe let's draw one. Let's draw up here. This is my cos graph, right? It's going like, this is just a normal cos, no, that's sine. This is my normal cos graph here. Okay, I need to reflect it, which means it would come this way, and then I'm moving it up. I'm changing the amplitude too, but that's the easy part. Okay, so it's going to have the shape of that red one, but moved up. Okay, so what I did was I had my starting point at the origin. I knew the period went to pi. Halfway in between that had to be my highest point, which would have had half to the middle of the graph, another half to get to the top of the graph. So 1 to get to the top. It doesn't actually say how much of this curve to sketch. We have done one complete rotation. If we wanted to, we could do more on the other side though. We could do another rotation this way. I've got the space there. And it would go like that. A bit wobbly, but yes. Okay? All right, so with those kind of graphs, try to work out all of your information first, period, amplitude, reflections, those kinds of things. Try to get your starting point and then work out using your period where everything's going to go from there. Okay, question 2. Let's get to the good part, the solving part. Let's solve the equation for 2 tan theta equals sec theta between 0 and 360 degrees. Now, we've got 2 parts here, a part A and a part B, because we're going to do this in 2 different techniques. because you are not restricted. You don't have to do it in a certain way. You might do it different to somebody else and still be able to get the same answer. So first of all, we're going to do it with good old-fashioned trig identities, which just means I'm going to break it down into sines and causes. So tan would be the same as sine over cos, or with the 2 at the front, it would be 2 sine theta over cos theta equals sec. What is sec equal to? 1 over cos. Okay, don't cancel because we might lose some solutions. So instead we're going to cross multiply, which means we will get 2 sine theta cos theta equals, and times the cos theta up to the 1, cos theta like that. Bring everything across to the left-hand side and we can factorize out that cos. I'll do that in 2 steps. So 2 sine theta cos theta minus the cos theta equals 0. Factorize the cos theta out. Okay, so using null factor, I'm either going to get solutions from this cos theta, either cos theta equals 0, or the bracket would equal 0, which means the 2 sine theta minus 1 equals 0. Where in degrees does cos theta equal 0? No, degrees. 90. So theta equals 90. There's another one. We're asked to solve between 0 and 360. 270. Okay, if we do the other one, we're going to have 2 sine theta equals positive 1. Divide the 2, so we've got a half. And sine of what gives a half? No, exact value triangle. Nope, wrong triangle. 30. Okay, which quadrant is sine positive in? So it's going to be 30 for the first quadrant, and in the second quadrant, 150, that's right. Now, we have done this we've been using our trig identities, but it's more of a kind of an algebraic practice rather than actually checking these solutions. So time is always a factor, but you should always check the solutions by subbing them back in to make sure that they actually work. And if you do that, let's try the 90, for example. If I go 2 tan 90, and then what does that equal? So, okay, tan 90, sorry, I can't do that. What's wrong with that? At 90. That's right. So even though it came up algebraically, there was a solution, it doesn't actually exist. What about 270? No, same deal. So these two solutions here, these ones actually don't work if you try to sub them back into your equation. So that means my solution is just the 30 degrees and the 150 degrees. Okay, let's do, yeah.
The 2 sine, what?
Because it's just multiplied to the top. Because if you put the 2 on the bottom, they would
right.
cancel out. We're going to do the same question again, but with a different, we're going to get the same solution, I would hope. But we're going to use a different method, which is to square both sides. If I square 2 tan theta, I'm going to get 4 tan squared theta. If I square sec theta, I'm going to get sec squared theta. Yes. So as soon as I've now made all of my trig functions into squared, we now have our Pythagorean identities that we can use. So the sine squared theta plus cos squared theta equals 1 is the one that is on your formula sheet. But we obviously want one involving tan and sec, which means you want to divide that equation through by cos, which would be that. Okay, so let's change the equation to either be all in tan or all in sec. I would have to say I prefer tan. Let's not use a inverse function if we don't have to. So let's change the sec to be tan squared plus 1. Okay, collect up the tan squared. So I'm going to subtract the 1 across the other side, would be 3 tan squared theta is equal to 1. And divide the 3. So it'd be 1 over 3. And to get rid of a squared, what do? And you don't forget something very important, plus or minus. Okay, and square root of 1 is 1. Square root of 3 we'll have to leave in surd form. So we are looking for solutions for tan that are positive or negative, so all 4 quadrants potentially, that give 1 over root 3. Exact value triangles, again, we already know the answer though. Yeah, it's good to have the answers there. Okay, so if you use your exact value triangle for 1 over root 3, it is 30 degrees for the acute angle. So you'd go 180 minus 30, you would get 150, 180 plus 30 to get 210, 360 minus 30 to get 330. However, the checking part again, if you check by subbing in, 2 of the solutions don't work. I wonder which ones. So it comes back down to our 30 degrees and 150 degrees. Okay, so just it's important that you check your solutions. Hopefully you can see that. Okay, question 3. Solve tan of 4x equals negative tan of 2x between 0 and pi over 2. So that's only 90 degrees. It's only the first quadrant. Using tan of 2 theta. So that's giving us a clue there that we want to use the double angle formulas. Because you can see in the equation that we've been given, we've got 4x on one side and 2x on the other. So one is twice the other, right? So the bigger one is the 4x. Let's use our double angle formula. Do you guys want to have a try? So if 2x is going to be my theta. No, don't remember the double angle formulas?
Tan squared 2x angle, no, tan 2x equals 1 minus tan squared.
One little thing you forgot was the 2 at the front. So there's a 2 and then tan 2x over 1 minus tan squared 2x. Okay, so that's just the one I wrote down. Yep, I wrote it down on the screen, double angle formula. Yes, so now we've got it all in terms of tan 2x. So what are we going to do? Yeah, how? Get rid of the denominator. Times the denominator across the other side. So let's leave 2 tan 2x equals, I'll show all the steps here. I'm going to leave the minus tan 2x and multiply up 1 minus tan squared 2x. Then I'm going to expand out the brackets. Is negative tan 2x. Negative and a negative makes a positive. What is tan 2x times tan squared 2x?
Tan.
Very good. No, yeah.
Oh, is this going to be a quadratic or are we going to?
We are indeed. Except that I think my video's frozen on me. My pen's frozen. They don't need this. They can do it without. Okay, back to it. We were expanding, which you've already done. tan cubed of 2x. Then you should have got it all on the one side. And the 2 tan 2x and then plus another tan 2x would make a 3, although I'm going to go the other way. It'd be minus 3 tan 2x equals 0. Okay, so then I'm going to factorize out a tan 2x, which will give a tan squared 2x minus 3. From the front of the bracket, either the tan 2x equals 0, or from inside the bracket, the tan squared 2x equals 3. All right, let's do each one of those. The tan 2x, we're solving for 2x. Where does tan equal 0? I would do it, I mean, we are asked to solve this in radians, but we often think in degrees first. So can you think in degrees? Where, yeah, 0. Is there any others? Where? What's the next one? 1, yeah, which is 180. And there would be 360. But it's good to have a few of them because we're solving for 2x, which means to get x, I now need to divide all of those by 2, which means 0, 90, and 180. So there's only 2 of them that I need. Let's convert them into radians. The 0, pi over 2, and pi. For the domain that I've been given, it means these first 2 solutions are the ones that I want. Okay, pi is still too big. But if I hadn't done the extra ones there, I would have missed one of my solutions. But I'm not finished. We now need to do the other side of the equation over here. So let's get rid of the squared. Tan of 2x equals plus or minus square root of 3. Exact value triangles. Tan of what gives root 3? Did you say 30?
Is it not 30?
60?
I do always wrong.
It is.
So it should be 60, but let's do a couple because we know we're going to be dividing these by 2. So what's the next one after 60 going to be? We put it into the second quadrant. Yep, 120. And that's probably, that'll be enough, to be honest, because the next one's going to be 240, which is going to be bigger than 90 degrees. Okay, all right, so let's divide that by 2. And that will be 30 degrees and 60 degrees. But in radians, how are you converting radians? We still remember how to do that? Yeah, so it becomes pi over 6 and pi over 3. So even though the solutions are separate there, you will see when you're looking at textbooks and whatnot that they'll like you to write your solution all as one big list. So 0 is the smallest, pi on 6, pi on 3, and then pi on 2 for solutions. We should check them, but we're going to keep moving so that we can get through this lesson. But yes, please keep in mind to check your solutions. Question 4. Solve cos 2x equals 4 sine squared x minus 14 cos squared x between 0 and 2 pi by changing all of the angles to x. In other words, I want to get rid of the double angle that is in there. What does cos 2x change to using my double angle formulas? Correct. I changed it to be the other, there's 3 different versions you can have. And I changed it to be the one involving sine and cos because I had sine and cos in there. But it's all right, different methods, right? You'll still end up in the same place. Let's change it to cos squared x minus sine squared x. Okay, let's have a look. The sine squareds and the cos squareds, let's collect them up. Move the negative 14 across to the other side. For the cos squareds would make a 15 cos squared x. And add the sine squared across would make a 5 sine squared x. Now, although it looks bad because we've still got two trig functions in there, can you see the silver lining?
No.
Sine and cos. If you've got just those together, if you divide through by cos, you'll be down to tan, and you're down to one function. Okay, so let's divide through by cos. So that would be 15
Can you just
cos
cancel
squared.
Cancel the 5.
Yeah, you can do that at the same time. Yep, do you want to do it at the same time? We're happy with that? So 3 equals tan squared x. Okay, then, like before, get rid of the squared. Tan x will be equal to plus or minus square root of 3. And exact value triangles, tan of what gives root 3? 60. So in the first quadrant, it's 60. In the second quadrant, 120. In the third quadrant, 240. And then 360 minus 60 is 300. I had to go all the way up to 360 degrees because I need it in 2 pi, and then convert each of those into radians. Okay? What do you think? Not too bad? Part B, same question, but different method. We're going to do it by changing them all into 2x's, change them all into double angles. So back on, let's go back to the very front page. Back here, see these little rules here. We haven't used these before, but they can be helpful for changing from squareds into your 2x's or your double x's. So if I'm trying to change my first one, which was sine squared, so I would just say sine squared is going to be equal to half 1 minus cos of 2x. I can use that little expansion there, or that little formula. Okay, so our rule was, I'll write the original equation down. So we started with cos 2x equals 4 sine squared x minus 14 cos squared x. That was the original question. We're changing the sine squared x using that formula that I just showed you. I'm going to leave the 4 out the front, and the sine squared becomes half maybe it is the charge.
It says 94.
It works. So plug it in for 30 seconds or 2 seconds. It's like it's going to sleep, do you think?
Yeah.
It's tired. It's had a hard week. No, I don't think so. But it wouldn't be good to go to sleep when it's being used. Yeah, check with the IT people. Anyway, let's do the same thing for the cos squared one. Leave the 14 out the front, and you flip back on your pages. This one's going to become half plus half cos 2x. You're okay with those formulas? So that means all my squareds are gone. I've got lovely double angles everywhere. Let's tidy it all up. Cos 2x equals 4 times a half is 2. 4 times negative a half is negative 2 cos 2x. Minus 14 times a half is negative 7. Minus 14 times a half is negative 7 cos 2x. All right, they are all cos 2x's. So let's collect them up. We have negative 9 on the right, so if we collect them on the other side, we will have 10 cos 2x's. And 2 take away 7 is -5. Getting easier, the more things we can cancel out. Divide the 10 away. 10. Okay, so that's -1/2. And we're now going to solve for 2x. Where is cos negative? Yeah, good. So I was going to say the second and third quadrant, the acute angle would be 60 degrees, which means 180 minus 60 is 120 for the first quadrant. For the second quadrant. For the third quadrant, it is 180 plus 60, which is 240. Because this is a 2x, do I have enough solutions there?
Yes.
No. I'm solving between to 2 theta, or a whole revolution, and I've got to divide by 2 here. I need to do another 2 solutions. So I have to add 360 on to each of those. So 480 and 600. So that when I divide by 2, they all come back in and fit between my 0 and 360. And they're the same solutions as before, which we can convert into radians. No, did you? All right. Question 5. Solve sine 2x plus cos 2x equals sine squared x plus 1 between 0 and 2 pi yet again. No suggested method here on what we should do. How about we change them out into normal x's? Get rid of the double angle? Yeah? All right, so what about sine 2x? What does it become? Correct. Okay, plus cos 2x. What does cos 2x equal? Bear in mind that there is a sine squared x on the other side. 1 minus 2 sine squared. So 1 minus 2 sine squared x is a good choice because we can see that we have a sine squared x on the other side that will hopefully collect up. Okay, now the 1 and the on both sides, if I subtract 1 from both sides, they are going to cancel out. Let's move the sine squared x on the right, let's move it across. So we have 2 sine x cos x minus 3 sine squared x is equal to 0. Okay, so I haven't actually gotten rid of, I got rid of the double angles, but I've still got a squared in there, but that's okay because I have a common factor in there, don't I? And I could factorize that out. So let's factorize a sine x out of both terms. That would give 2 cos x minus 3 sine x, close bracket, equals 0. And here we go with null factor again. Either sine x equals 0 or the 2 cos x minus 3 sine x equals 0. Now, sine x equals 0. What does x equal?
0.
Good. Straight to radians. Nice. Okay. For the other one, sine and cos, which means I'm going to have to change something into tan here. So let's put the 2 cos x equals 3 sine x, make it positive. I'm going to divide the 3 across, so it'll be 2 over 3. And then sine over cos will be tan, but I'll do it in an extra step for you. There you go. Sine over cos. So it becomes tan x equals 2 over 3. So that is not an exact value one. We would be forced to go to a decimal here. you would need to have your calculator in radians so that it gives you radians answer. So inverse tan of 2 over 3, what do you get? In radians. Yeah. Okay, that's the first solution, which would be the solution in the first quadrant. There would be another solution in which quadrant? No, it's only positive tan. Where is tan positive? First and third. So to get the other solution, what should I do? It's not 180 plus, it's already in radians.
6.2.
Pi will be fine, but yes. So on your calculator, type in pi plus the 0.59. Yeah, because it's 180 to move it into the third quadrant. So we've got 0.59 for the first solution, and it should be 3.73 for the other one when you type in what pi plus 0.59 is. Yeah? 1.31.
Yeah.
Type it in again. Type in pi, because pi is 3. So it should be 3 plus 0.59. So,
No.
yeah. Yeah. All right, that is our first lesson done.